Have you ever wondered how your favorite music players manages its playlists? How it plays the next song, goes back to the previous one, or loop tracks without breaking? In this series, I will break it down and show you how data structure and algorithm power these real-world features behind the scene. Take a look at the demo. Take a look at this demo project. Does it look like your favorite music player? I don't think so, but it serves its purpose. The main idea is to see the various features that we're going to work on. For example, we can play a sound. If I click on this play button, we can hear the sound behind the scene, and we can play the next sound. We can see here indicates that playing song 2. The duration is here and it indicates the next song and the previous song. So we can play the next song again, the next song again. So in total we have 4 songs. Alright, so if I press next while we are at song 4, it's gonna go back to song 1. So it's gonna loop back to song 1. And we can also, from song 1, we can press the previous button and it goes to song 4. So this is what we are going to be working on. But first, let me pause this. But first, we are going to use or explore a naive way of implementing these various features. Then we're going to introduce a data structure that is going to help us to handle this more efficiently and elegantly. Before we implement anything, let's understand the project structure and the requirement. So our music player is a KVMT app that you can find in the data structure and algorithm in real life repo under the linked list folder. So in this folder, we have some subfolders. We can see the starter. This is where you can attempt your own solution. We have the naive folder. This is where we're going to implement the naive solution, and the DSA, this is where we will implement the data structure and algorithm solution. All right, so if we go to the starter, all right, so right here we have the main.py. The main.py is the entry point to our application. So we have a few libraries that we are using here. First one is this mutagen, which is used to extract information from the mp3 song that we have. Okay, so here we have the music player class, and this class is going to receive a playlist, which will be the implementation that we'll see very soon. And here we can see we have sound, which is set to none, and we have a very important method here, the play current. This play current stops the whatever sound that is currently playing, and it extracts the current song. So our playlist that we will implement using the naive implementation and the data structure and algorithm needs to have or must have a current attribute that will hold the current song. Okay, and once we have the current song, we will extract it from the file, and we're gonna load it with the sound loader that comes from the Kiwi audio library. And here we have the play, we have the stop, we have the next, and the previous. These two are very important because this is where we'll focus our attention. Okay, so we have here, when we want to play the next sound, we need to get the next song from the playlist. So our playlist needs to implement this method. Same thing with the previous song, our playlist needs to implement the previous song. And when we go down to the player UI, this is not really important. This just make sure we have that cool UI that we saw there. We don't really need to work on this, but we can see here when we press on the previous button, it calls this method. And when we press the play and we press the stop and we press the next. Okay, and down here we can see at this level down here in the music app, we kind of like load the songs. Okay, we load the songs into our playlist. So our playlist needs to have the add song method. Okay, so basically that's it. And when we go now to our DSA, that's kind of like contain the implementation of our playlist, we can see some few instructions. Okay, most of these methods are not implemented, but this is like a starting point to give you an idea of what you need to implement. So we need to implement the add song, the next song, and the previous song. All right, so let's start with the naive implementation. Okay, for the naive implementation, we will use a simple list alongside a class to represent the song. So each song is modeled as an object containing the different attribute that we need for the song. So for example, let's call the class song, and this class will have some attributes. The first one is going to be the title of the song. Second one is going to be the duration, and the last one will be the file path. Okay, and we are going to maintain a list that will contain all the different songs that we need for our playlist. So let's call this one PL, which that stands for playlist, and let's partition this so that it holds the various songs. So let's say we have here song 1, song 2, song 3, song 4, song 5, song 6, and this is a 0 index base. Okay, so Python always maintains a 0 index base for its list. So here it's gonna be the first song will be at index 0, next one 1, 2, 3, 4, 5. Okay, so our current song or current index, the current index that will hold the current song will be at 0. That is, when our music player starts, it starts at index 0. So the song that we play will be song 1. Okay, to move to the next song, all we need to do is to increment the current index. So let's use ci that represent the current index. So we say ci plus 1, that will be 2. Okay, oh, that will be 0, sorry, 0, that will be 1, that will be 1. So it means that what, when we are at the current index 0, we press the next button, it's going to move to index 1, that will play the song 2. Now for the previous song, all we have to do is to decrement the current index. So let's say we already incremented once and we are at index 1 and we are playing song 2. If we want to go to the previous song, we will decrement the current index, which is at 1, and we will go back to 0. Perfect. Okay, so now there's an issue here. If we want to support circular playback, we will have an issue. The issue is that, let's say for example, we are at this level, we are here. Okay, the last song. So the last song, at the last song, we have the current index to be 5. If we want to play the next song, we will have 5 plus 1, which will be 6. Okay, but when we take a look at our list have a length of 6, meaning that index 6 is out of bound. So this will result to index error. Okay, same thing here. Let's say we are at current index, our current index is at 0, and we want to play the previous song. We will have 0 minus 1, which will be -1, leading to index error. Okay, now to overcome this, we need to use modulus. Okay, so for example, let's say we are here and we want to play the next song. We will say 5 plus 1 modulus the length of our playlist. The length of our playlist is 6. Okay, because if you start counting here, 1, 2, 3, 4, 5, 6. So this modulo 6 will be 0, meaning that when we are at the last song here, if we press the next button, it's going to take us back to index 0. Same thing here. If we are at this level with a current index 0 and we want to play the previous song, it will be 0 minus 1 modulus 6, which would be 5. So if we are here, want to play the previous song, it's going to take us to index 5. So that's how we avoid the index error and support secular playback. So let's take a look at this implementation in Python. Alright, so for the implementation, we move to our naive folder where we will see the dsa.py. Alright, so we needed two things. We need a class representing our song and a list that will hold all our songs. So here we can see we have a class that set the different attributes of that song, the title, file path, and duration. And when we go to the playlist, we can see here in the init method, we have the serve.current. All right, so we needed this to get the current song, and we have a song list, okay, that holds all our song, and we have the current index, which is set to 0 initially. All right, so our first method is the add song. It takes all the properties of the song and it instantiates the song class and assign it to the song list. Here we just want to make sure that the serve.current references the first song. That's why we check if this was set already. If it wasn't set, if it hasn't been set already, we go ahead and set it to the first song. Okay. Now moving down to the next song method. Okay, what we do is that we increment the current index and we use the modulus here to support secular playback and avoid index error. Once we have once we update the current index, we go ahead and fetch the song from the song list using that index. Same thing with the previous song. We decrement the current index and we use modulus, okay, to avoid index error. And we go ahead and fetch the song based on that current index value. So basically that's it for our naive implementation. Let's go ahead and test that. And here I'm going to use uv run python main.py once I have that running. So let's go ahead and play the current song. So playing song 1. When we press next, it increments the current index and use modulus to avoid index error, and we have song 2. Next song, song 3. Next song, song 4. So in this category, we have just, in this playlist, we have just 4 songs. So if I'm on the last song, which is song 4, and I press next, it's going to take me back to song 1. And here I can press also previous, it takes me back to song 4, previous, and so on. So that's our implementation, that's our naive implementation. For a more efficient and scalable approach, we will use a linked list to represent the playlist. Each song is modeled as a note containing the attributes of the song, like title, duration, and file path. For example, let's say we have a note here. This will represent our note. And here, the note holds the different attributes of our song. So we have the title, we have the duration, and we have the file path. Okay. Now, a note holds a reference to the next note. Okay. So let's say the next note is this. Has a title. Okay. So this is the first note, usually referred as the head. And this is the last note. Okay. And the last note's next pointer points to none. Okay. Now, this is what we call singly linked list. Okay. Now, so this is the next note. This is the next note. Okay. So in our music player application, we need to have our note need to have reference to the previous note. That is, the current song needs to have reference to the previous song. So in this case, we're going to use another pointer called previous. So here there will be a pointer here going to the previous note. So it means that the head here, the previous pointer of the head will reference none. Okay, will be assigned to none. So let me have that. So this is none. Okay, so this is what we call doubly linked list. Okay, let's say this one represents song 1. Okay, this one represents song 2. All right, so the current index, or we're not going to use current index, let's just use the current notes. Okay, let's use current note here. All right, the current note will be the head. So in linked list, the head is usually the first note. Okay, that is the first note in the linked list. Now, for us to have the next note or the next song, in this case song 2, we will say current note point next. It means that we are going to use the next pointer to get the next note. So we can see here the next pointer points to song 2. So when we do that, we will be at the note that contains song 2. If we are here at the note that contains song 2 and we want to get to the previous note or the previous song, then we'll say current note dot previous. This will take us back to song 1. Good. Now, for us to support secular playback, we need to make sure that the head, okay, or the first note has access to the last note, okay, and the last note has access to the next to the head note. Now, this is very simple here because we have just 2 notes. Okay, if we go ahead and introduce another note, it's gonna be a little bit tricky. So for us to support secular playback, we need to make sure that the next of the last note point back to the head. Okay, because if we are here at the note that contains song 2, we want to say current note next is gonna end up in none. Okay, so for us to avoid that, we need to make sure that the pointer here point back to the head. So this pointer will point back to the head, and then the previous pointer here will point to the last note, because if we are here at this note that contains song 1, we want to say current note dot previous is gonna hit none. So for that, we need to make sure that this pointer points to the last note. Okay, so once we have that, we have what we call doubly secular linked list. Okay, doubly secular linked list. So with that, even if we are here at song 2, we can say current note dot next is gonna go to the first note. If we are here, we say current note dot previous is gonna take us to the last note. Okay, now this is the demonstration. This is what we are going to use. So we have demonstrated how we're going to represent our songs, and also how we're going to access the different songs. Now let's demonstrate how we are going to add songs into our linked list. Okay, if we want to add songs to our linked list, we are going to use we are going to just play around with the pointers. So let's have this. This is what we have. Let's say, for example, we have already 2 songs. Okay, this one goes here, this one goes here, this one goes here, and this one goes here. Okay, same thing like we did here. If we want to add another song, we are going to add it at the end here. Now we want to make sure that the pointers point to the right places. Okay, so the previous pointer of this new note will point to the last note. Okay, now the next pointer of this note here will need to point to the new note instead of pointing back to the head note. Okay, so we're going to erase this part here instead of pointing, and erase this part as well. Okay, so the next pointer of this note will point to the new note, and for the new note, its next pointer will now point to the heads like this, and the previous pointer of the head will point now to the new note. So this is how we add notes into our doubly circular linked list. Okay, so let's see how this is implemented in Python. The linked list implementation of our solution is found in the DSA folder under the music player of our repo. So here we can see, if we go to the DSA folder, we have the dsa.py file. And in there, we have the notes. Our song note is defined with this class. And we can see the different properties that this contains. It contains the properties of our song, that is the title, file path, duration. It contains also two pointers, the next pointer and the previous pointer. Okay, so if we go to our playlist class, we can see here we have the head. We said already that the head refer to the first note in our playlist. Okay, so right now let's assume that our playlist is empty, so this is gonna be none. And the serve.current kind of like give us access to the current note or the current song. It is also none or empty. Now this is a method that adds songs to our playlist, and we already demonstrated that, and we said we play around with pointers in order to make that happen. When the add song is called, it receives the different arguments, that is the title, file path, and duration. And here we can see we create an instance of the song note. Okay, and here we just find out if our playlist is empty. Okay, if our playlist is empty, means that the head is none, because remember the head access the first note in our playlist. Okay, if it is none, it means that there's nothing in our playlist. If that is true, then we just assign the new song to the head, and we play around the pointers here. So the pointers of the head will point to itself, the next pointer of the head will point to itself, the previous pointer of the head will point to itself as well. And here we just set the current to refer to the head. Okay, but if we have already songs in our playlist, then we want to get access to the last notes or the last song in our playlist. In this case, how do we get that? We get that by using the head.previous. So we said the previous pointer of the head points to the last note. So here we get the tail, which is the last note, and the last note, the next pointer of the last note will point to the new song that we are adding, and the previous pointer of the new song will point back to the tail. Okay, this is the tail that used to be the last note, but now it is no more the last note. The last note is now the new notes that we are adding. And here we make sure that the next pointer of the new note we're adding points to the head, and the previous pointer of the head now points to the new note or to the new song. Okay, so that's how we add notes or songs to our playlist. Moving down, we have the next song. So how do we get the next song? We check if the current song is set. If it is set, then we just say, okay, we want to get the next, which will be achieved by calling the next pointer of the current song. Okay, let's say the current song is song 1. So we want to get the next song. We just need to call the pointer of song 1, and it's going to lead us to song 2. Same thing here. If we want to get the previous song, then let's say we are at song 2. Then what we do is that we just call the previous pointer of song 2, and it's going to take us to song 1. So that is how we implement this using linked list. So let's go ahead and run the application and see what will happen. So once we run that, we can see here it is more populated, okay, because we can now customize it, okay, to add more functionality. This wasn't possible with the naive implementation. So how do we get the next song? How do we get the previous song? So we can come back to the main here, and if we go down somewhere down here, okay, so here, once we have the current song, okay, we can go ahead and say, okay, if we want to get the next song, what will be the next song? Like to project what the next song will be, all we have to do is to say song.next, and we get the title. Okay, this is going to give us the next song. Okay, it's gonna project the next song. If we want to project the previous song, we just say song.previous and we get the title, and it's gonna project the previous song. This is very easy to do with linked list, but with the naive implementation, we'll need to play around with the index and with the entire list in order to get this information. So that's one advantage of using linked list. We can easily customize and it is scalable. So going back to our application, so we can play the song and play the next song, play the next song, play the previous song, and so on and so forth. All right. All right. Just for the record, these are all my beats. Okay, these are all my beats. I'm a beat maker as well. So what's the difference between the naive implementation and the linked list implementation that we just saw? With linked list implementation, moving to the next or previous song is just pointer movement, no index tracking needed. With linked list, no more worrying about going out of bound or managing index manually. Secular playback in linked list becomes more natural, no modulus tricks required. With linked list, your logic stays clean and scalable as your player grows in future. Thanks for watching. Be sure to come back for more as we keep exploring data structure and algorithm and how they apply in real life or real world scenarios. You are encouraged to review the standard code and build your own implementation. If you believe there's a data structure or algorithm that works better than the linked list we just explored, I would love to see your version. Go ahead, fork the repo, implement your solution, and submit a pull request. If you're new to this channel, don't forget to subscribe, like, share, and comment to support the content. Code with Eno. See you in the next video.